Find the vector equation of the plane passing through the intersection of these two. So here also the same thing actually will go. First equation of the plane is r dot 2I plus 2j minus 3k cap minus 7 is taken left hand side is equal to 0. This is the first plane, and the equation of second plane is r dot 2I cap plus 5j cap plus 3k cap minus 9 is equal to 0. And passing through the point. So here also the same thing, we will do the same thing. Equation of a plane passing through intersection of planes 1 and 2 is, write the first equation 2I cap plus 2j cap minus 3k cap minus 7. Okay, plus that we did in the Cartesian form of this lambda times the second equation. Lambda times second equation r dot 2I plus 5j plus 3k minus 9 is equal to 0. Okay, r dot is common. If you want, you can take outright common. R dot is common, dot product. Then you can solve this one. R dot 2I plus 2 lambda I. So this will become 2 plus 2 lambda I cap, means coefficients of I cap. From that you take I cap common. Then 2 plus 5 lambda j cap plus here minus 3 and 3 lambda. So because of 3 lambda positive, 3 lambda first we are writing 3 lambda minus 3k, and now bring the constant terms right hand side. This is minus 7 will come right hand side and 9 will come right hand side. 9 lambda plus 7. Yes, your question is correct. We are taking r dot common, not from minus 7 and minus 9. We are taking r dot common from this and from this. Okay, and minus 7 and minus plus 9 lambda is taken right hand side. Minus 9 lambda will come here right hand side. 9 lambda minus 7 will become plus 7. Okay, got it? Okay, this is the plane number 3. You can say this is the plane which is passing through the intersection of the given two planes. Now again we have given that that plane lies, means point, now point P whose coordinates 2 and 3 lies on 3. So here you can see xyz is this one, so therefore the position vector, because we are writing the vector position vector when the point is lying, therefore convert into position vector. Its position vector will be 2I plus j plus 3k, that is r. That will be the value of r. This you can put in equation number 3. So we get, instead of r you will write 2I plus j plus 3k and its dot product with 2 plus 2 lambda I plus 2 plus 5 lambda j plus 3 lambda minus 3 k cap is equal to 9 lambda plus 7. Just find the dot product and then solve it to get the value of lambda. Put the value of lambda in 3, you will get the required plane. So now dot product. So 2 will multiply with 2 plus 2 lambda. J is 1, so 2 plus 5 lambda, and 3 will multiply with 3 lambda minus 3, and right hand side is 9 lambda plus 7. So 2 2s are 4 plus 4 lambda plus 2 plus 5 lambda plus 3 3s are 9 lambda minus 9 is equal to 9 lambda plus 7. इसको खत्म कर दो. 5 lambda plus 4 lambda 9 lambda and 4 plus 2 6. 4 plus 2 6. This is a 9 lambda. This is also 9 lambda. Minus 9. So 9 lambda. 9 will come this side. So 4 5 6. 9 minus 6. Something wrong. We did 2. 1 multiply with 2 plus lambda. 9 lambda. 9 lambda minus 9, 2 plus 5 lambda, 4 plus 4 lambda. So 5, 4, 9 lambda, 4, 5, 6. 7, I forgot this one. Sorry. So 9 minus 6 plus 7, that is equal to 10. So therefore lambda is equal to 10 by 9. This value of lambda, next step from here, you will come to this point. Now put lambda is equal to 10 by 9 in equation 3. Okay, equation 3 is r dot 2 plus 2 lambda. 2 plus 2 lambda. Sorry. This equation, either you write like this or you can put here, then solve it. Same thing, no problem. So we can do 2 plus 2 lambda. 2 tens are 20 by 9 iota. Okay, plus 2 plus 5 lambda. 5 tens are 50 by 9 9j plus 3 lambda means 3 3 are 9, so 10 by 3 minus 3k is equal to 9 times lambda, so 10 plus 7. So ultimately we will get r dot 9 2s are 18 plus 20, so 38 by 9i, and 9 2s are 18, so 68 by 9 to j plus 3 3 is a 9, 10 minus 9, 1 by 3k is equal to 17. and 9, or we can take the 9 LCM. So, and 9 will bring on right hand side. So the final answer will be 38 I cap plus 68 J cap plus 3 K cap is equal to 17 nines are 153. So this is the which is the vector equation of the required plane, which is the vector vector equation of required plane. Okay, got it? Find the equation of the plane through the intersection and is perpendicular to the plane. Yes, intersection of the plane means first plane is x plus y plus z minus 1 is equal to 0. Plane number 1. Plane number 2 is 2x plus 3y plus 4z minus 5 is equal to 0. Second plane, and this plane is perpendicular to the third plane. Third plane is x minus y plus z is equal to 0. Third plane. Okay, when here the condition of perpendicularity, if you remember, I'll write and then I will remove it and then we will apply there. The two planes are perpendicular if a1 a2 b1 b2, their dr's are a1 a2 plus b1 b2 plus c1 c2 is equal to 0, then planes are perpendicular. Planes are perpendicular. Okay, so this condition will be followed. First we will write the plane which is passing through the intersection of these two planes, and that plane is perpendicular to third plane. So equation, first we will find the equation of plane through intersection of 1 and 2, intersection of 1 and 2, plane 1 and plane 2. So that we did in the previous question, x plus y plus z minus 1 plus lambda times 2x plus 3y plus 4z minus 5 is equal to 0, or you can write 1 plus 2 lambda x plus 1 plus 3 lambda y plus 1 plus 4 lambda z is equal to, or you can write here also, or you can bring other side also. So 5 lambda and minus will become plus 1. 5 lambda plus 1. Okay. And this is equation, this is the plane number 4. And which is perpendicular? Plane, it is given that the plane 4 is perpendicular to plane 3. Correct? Because it is given that it is perpendicular to the plane this. So this is the given condition. It will be applied when two planes are perpendicular. A1, A2, B1, B2. A1 is 1, B1 minus 1, C1 1, A2, B2, C2. This will be A2, B2, DRs and C2, and A1, B1, C1. So our condition will be A1, A2 plus B1, B2 plus C1, C2 will be equal to 0. So 1 into 1 plus 2 lambda, 1 plus 2 lambda, minus 1 into minus 1 minus 3 lambda, and 1 into 1 plus 4 lambda, 1 plus 4 lambda is equal to 0. So 4 plus 2, 6 lambda minus 3 lambda, 3 lambda minus 1 plus 1 cancelled. Only 1 is left here, so that will come minus 1. Lambda is equal to minus 1 by 3. Lambda is equal to minus 1 by 3. This value you can put in equation number 4. we get the required plane. Put in 4, plane 4 है ना, you should use to write plane 4 huh? I'm writing directly, so it will become 1 minus 2 by 3 x plus 1 minus 3 by 3, that is 1 minus 1, plus 1 minus 4 by 3 z is equal to minus 5 by 3 plus 1. So 3 minus 2, 1 by 3, x by 3, this will become 0, plus 4 minus, so minus z by 3 is equal to minus 5 plus 3 by 3. So 3 will cancel, we get the equation x minus z is equal to minus 2. So x minus z plus 2 is equal to 0 is the required equation. X plus z minus x minus z plus 2 is equal to 0, which is the required equation of the plane. Find the angle between the planes. Here n1, this is what n1. So in this plane n1 means normal to the vector is 2i plus 2j minus 3k, and normal to another vector is n2 is equal to 3i minus 3j plus 5k. Okay, so I told you that finding the angle between the planes is the same as the angle finding between the normals to the plane. So normal to the, so we will find the angle between n1 and n2, that will be the angle between the planes. So that is equal to n1 dot n2 on magnitude of n2, n1 into magnitude of n2. Find the dot product n1 n2. You allow me, I will do it directly. n1 dot n2 means 2 3 is 6. So cos theta will be equal to 2 3 is 6, and this 2 will multiply with minus 3, 6, minus 3 will multiply with plus 5, minus 5 3 is 15, divided by under root 2 square 4 plus 2 square 4 plus 3 square 9. Magnitude of this one and magnitude of this one is 3 square 9, 3 square 9, 5 square 25. This cancelled, we get 15, here 15, and in the denominator, when you will solve that, both this will come under root 17 and this will come under root 43. They will not cancel. When you have to multiply, under root 731 will come. Therefore the angle between the planes is equal to cos inverse 15 upon under root 71. Okay, this is acute angle, as I told you before also. Whether the planes are parallel and or perpendicular, in case they are neither, find the angles between them. Okay, so first find whether they are parallel or perpendicular. Okay, you know that perpendicularity and parallel condition. If so, first you will take this one. Okay, a1 b1 c1. First plane is 7x plus 5y plus 6z plus 30 is equal to 0, and this is plane number 1. Plane number 2 is 3x minus y minus 10z plus 4 is equal to 0. This is plane number 2. And what is a1 b1 drs? Here a1 is equal to 7, b1 is equal to 5, C1 is equal to 6. Okay, no need of D. A2 3, B2 is equal to -1 and C2 is equal to -10. Now we have to check whether they are parallel or perpendicular. Parallel means A1 upon A2, B1 upon B2 is equal to C1 upon C2. To find, first check A1 upon A2, that is 7 upon 3. Then B1 upon B2, that is 5 upon -1. They are not equal. So you can say this plane 1 is not parallel to plane 2. Now check for perpendicularity, that is A1 A2 plus B1 B2 plus C1 C2. So A1 is 7 into 3 plus 5 into -1 plus 6 into -10. 7 3 is 21 minus 5 minus 60. So not parallel. It is not coming equal to 0. That means they are not parallel. So that means when they are neither parallel nor perpendicular, then we can find the angle between them. In this case, we can find the angle between them. Now, finding the angle between them in the Cartesian form, the formula is cos theta is equal to A1 A2 B1 B2 A1 A2 plus B1 B2 plus C1 C2 upon under root A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square. So then we can put the value 7 3 is 21. A1 B1 C1, I told you this is A1 B1 C1 A2 B2 C2. A1 A2 7 3 is 21. B1 B2 5 minus 5. C1 C2 60 divided by under root 7 7s are 49, 5 5s are 25, 6 6 are 36, and second 3 3s are 9 plus 1 square 1, 10 square 100. To solve it, ultimately you will have the figure 44 by 110 will come, and you can solve it, get 2 by 5. So theta is equal to cos inverse 2 by. So if they neither parallel, whether the plane parallel or perpendicular, in case they are neither parallel nor perpendicular, then find the angle between them. Otherwise, you will stop there. Okay. The last point is we have to find the perpendicular distance from a point on the plane. This is a plane, and we have to find the distance. We can take the B, 14th B. It is very easy. Just you put the value of x, y, z and under root a square plus b square. Yeah, this is a1. Is coefficients a1, b1, c1 capital. We are taking capital, huh? And this is d. Or yes, d. Then perpendicular distance from this point. This point is x1, y1, z1. Then perpendicular distance formula is a x1 plus b y1 plus c z1 minus d, because d we are taking right hand side. Ax plus by plus cz is equal to d. So this is minus d. Actually, this will come here, then it will be d. D is equal to -3 here. Okay. And divided by under root a square plus b square plus c square, a square plus b square plus c square. Just you have to put the values in this formula. So therefore, the here in this question number B, a, what is a? A is 2. x is replaced by 3, minus y is replaced by minus 2, and plus 2z, z is replaced by 1, and plus 3, d you bring left hand side. So then under root a square plus b square means 2 square 4 plus 1 square 1 plus 2 square 4. So 4 plus 4 8 plus 1 9, so that is 3, and numerator is 13. So 13 by 3. Left hand side, always take d left hand side. Full equation will be written on left hand side and then put the point. That's it. Do not confuse with d. So distance is 13 by 3 units. That's all. So this is all about 3D. Okay.